Chapter 14, the Atmosphere. Section 1, Characteristics of the Atmosphere. Before you read, after you read this section, you should be able to answer these questions. What is Earth's atmosphere made of? How do air pressure and temperature change as you move away from Earth's surface? What are the layers of the atmosphere? What is Earth's atmosphere made of? An atmosphere is a layer of gases that surrounds a planet or moon. On Earth, the atmosphere is often called just the air. When you take a breath of air, you're breathing in atmosphere. The air you breathe is made up of many different things. Almost 80% of it is nitrogen gas. The rest is mostly oxygen, the gas we need to live. There's also water in the atmosphere. Some of it is invisible in the form of a gas called water vapor. Water is also found in the atmosphere as water droplets and ice crystals, like those that make up clouds. The atmosphere contains tiny solid bits or particles too. These particles are things like dust and dirt from continents, salt from oceans, and ash from volcanoes. So here we've got the answer to our first question. What's the air made of? The air you breathe is made of many different things. Almost 80% is nitrogen. Here we see that it says 78%. The rest is mostly oxygen at 21%. And then there's lots of other gases. There's also water in the atmosphere. Some of it is invisible in the form of a gas called water vapor. Water is also found in the atmosphere as droplets and ice crystals, like those that make up clouds. The atmosphere contains tiny solid bits or particles too, and these particles are things like dust and dirt from continents, salt from oceans, and ash from volcanoes. List which two gases make up most of Earth's atmosphere. So like we've said a couple of times at this point, the two main gases in the atmosphere are nitrogen and oxygen. Notice you don't hear anything about carbon dioxide. Math focus. Analyze data. About how many times more nitrogen than oxygen is there in Earth's atmosphere? So we're just going to divide approximately 80 by approximately 20, and we end up with 4 times more. Why does air pressure change with height? Air pressure is how much air above you weighs. It's a measure of how hard air molecules push on a surface. We don't normally notice air pressure because our bodies are used to it. As you move up from the ground and out towards space, there are fewer gas molecules pressing down from above. Therefore, the air pressure drops. The higher you go, the lower the air pressure gets. Why does air temperature change with height? Like air pressure, air temperature changes as you move higher in the atmosphere. Air pressure always gets lower as you move higher, but air temperature can get higher or lower. The air can get hotter or colder. Air temperature depends on a number of things, including the gases that are present in the atmosphere. There are different layers of the atmosphere, and each layer is made of a different combination of gases. Some gases absorb energy from the sun better than others. When a gas absorbs energy from the sun, the air temperature goes up. What are the 4 layers of the atmosphere? There are 4 layers of the atmosphere: the troposphere, stratosphere, mesosphere, and thermosphere. You cannot actually see these different layers. The atmosphere is divided into layers based on how each layer's temperature changes. The table on the next page shows the features of the different layers of the atmosphere. So if you'll remember, our second question was, how do air pressure and temperature change as you move away from Earth's surface? And here we've got both of those things. Starting off with air pressure, right? As you move up from the ground and out towards space, there are fewer gas molecules pressing down from above. Therefore, the air pressure drops. The higher you go, the lower the air pressure gets. And as far as temperature, air temperature depends on a number of things, including the gases that are present in the atmosphere. There are different layers of the atmosphere. Each layer is made of a different combination of gases. Some gases absorb energy from the sun better than others. When a gas absorbs energy from the sun, the air temperature goes up. Question number 3, reading check. Explain, why does air pressure drop as you move away from Earth's surface? Well, as we can see here, there's less gas weighing on you. Question number 4, take a look. Compare. How is the air pressure around the tree different from the air pressure around the plane? Well, if you look, you can just tell the air pressure is higher around the tree than it is around the plane. Question number 5, reading check. Summarize. What's the main idea of this paragraph? Like air pressure, air temperature changes as you move higher in the atmosphere. Air pressure always gets lower as you move higher, but air temperature can get higher or lower. The air can get hotter or colder. Well, it seems that it's saying that unlike air pressure, air temperature can get higher or lower as you go up in the atmosphere.
So it seems like changes in temperature between the different layers can be complicated. So we're going to take some notes on our diagram of the layers of the atmosphere to help us understand. Please draw and write the notes I make. We're going to follow Phillip the Photon on his journey through the atmosphere. So we're going to draw Phillip as just a little bit of sunshine here, because that's what he is. He's just a little bit of sunshine, like each one of you. And maybe we'll put some lines in to show him moving through the atmosphere. So we start off, unlike the textbook, with another layer which they haven't listed, and this one's called the exosphere. Now there's so little matter in this layer that it's hard to tell that it is in outer space. Remember, Phillip and his fellow photons have just spent the last 8 minutes traveling through the vacuum of space to get here, so they are very hot, unlike the surface of the sun. Since outer space has no matter, they have the same energy they had when they left the sun 8 minutes ago. When they bump into molecules of gas in the thermosphere, they cause their average kinetic energy to speed way up, so it's super hot. If you're near the poles, you can see this heating up the atmosphere as the auroras. But Phillip and his friends don't pass much heat to this layer and the next after that original blaze, because, like I said, there's so little mass in the thermosphere and the mesosphere. There's so little density. The majority of the matter or gases in the atmosphere really begin at the top of the stratosphere. Near the top of the stratosphere is the ozone layer. Many important heat-absorbing gases or ozone gases collect in this layer of the atmosphere. Because these gases react so strongly to the sunlight, this again is a hot layer of the atmosphere. Other gases in the stratosphere and the troposphere, which settle lower than the ozone gases, don't react with sunlight as much. So our Phillip and his photon buddies make it down to the surface of the Earth, where they transfer their heat to it as radiation. This radiation unevenly heats the surface of the Earth, as we saw in our section on the ocean currents. Now, in some places, this radiation heats the surface of the Earth like an iron heating up. If you've ever held your hand near an iron that was hot, you probably notice that if you hold your hand a few feet away from the iron, you don't feel the heat. But as you hold your hand closer and closer to the iron itself, you can feel the heat more acutely. Just like this, the atmosphere loses heat drastically as you pull away from where the surface of the Earth is passing its heat by directly contacting the molecules of gas in the atmosphere. Can you remember what type of heat transfer that is? Direct contact? That's right, it's conduction. So if the top of this fluid, the atmosphere, is cold, we know when a fluid gets cold, it sinks down. It sinks down. And at the surface of the Earth, when this fluid, the atmosphere, gets hot, it floats up. It floats up. When the fluid gets hot, it floats up. Now, what kind of heat transfer was that? That's right, it's convection. This convection of atmospheric gases is experienced by us living creatures on the surface of the Earth as weather and climate. You can feel the atmosphere convecting every time the wind blows through the trees. Now, some of the heat from the surface of the Earth makes it up through the stratosphere, but whatever heat makes it this far, again, is absorbed by the ozone layer. This has a real double whammy effect on the mesosphere. No radiation from above, no heat from the surface below. It causes the mesosphere to be super cold. Okay, while it's fresh in your mind, get out that red crayon and highlight the answer to our third question. We now know the layers of the atmosphere. Critical thinking. Number 6, explain events. How do you think scientists find out that there are 4 layers of the atmosphere? Why don't you think about that and put something down? I don't want to give you my idea. Question number 7. Take a look. Identify. At what altitude does the mesosphere end and the thermosphere begin? Well, if we look over here at the graduations on the left-hand side of our graph, we see that it's around 80 kilometers. Now that we've finished the reading, you can go back and start your section review questions. Try to remember to use this reading while you're answering those section review questions. It's going to make it easier.